Hello and thank you for joining Mr. A's Maths Today. Here's today's question. When you're ready, pause the video and give it a go. Tough question today, but it's still a foundation and higher. This will be towards the end of a foundation paper. Let's see what it says. The diagram shows a regular hexagon. Hexagon means 6. This is a 6-sided shape made from 6 equilateral triangles. Equilateral means all sides are the same length and each angle is the same. More importantly, for an equilateral triangle, every angle is the same, which means that it has to be 60 degrees. For an equilateral triangle, every angle is 60 degrees. Each side is 10 centimetres. Each side of the hexagon is 10 centimetres. The angle ACB is a right angle triangle. Show that AC, this is a length, equals 8.66. Correct to 3 significant figures. Okay, because this is an equilateral triangle, I know if that's 10, that's 10, and that's 10. This line splits this triangle in half. So what must this length be? This length has to be 5. So I've got a triangle with length 5 as one of the shorter sides and 10 as the hypotenuse. They want me to show that AC equals 8.66. If I've got a right angle triangle and I've got 2 sides, the only thing I can use is Pythagoras theorem, or the most sensible thing to use is Pythagoras theorem. It depends how your teacher has shown you how to do Pythagoras, but I'm going to call that A, I'm going to call that B, I'm going to call that length C. Length A, length B, length C. I know that A squared plus B squared has to be equal to C squared. That's Pythagoras theorem. You may have been shown a slightly different way if you have used the way you've been given. A squared 25 plus B squared equals 10 squared, which is 100. So B squared has to be equal to this 100, subtract 25, which equals 75. Therefore, B equals the square root of 75. This is a calculator question. I'm going to use my calculator. The square root of 75. My calculator is saying 5 root 3. I don't know if you can see that, 5 root 3. To get it to a decimal, I'm going to press the button that says SD, changes my standard to a decimal, and it gives me, actually gives me 8.660254 and a few more digits. Want it to 3 significant figures, 1, 2, 3. The next number is 0, so I can just ignore that, which gives me 8.66. So I've answered that first one. It's on Pythagoras. Even though we're looking at the area of a right angle triangle, I've had to use a bit of Pythagoras. They loved the questions towards the back of the paper for foundation and anywhere on higher to use a mixture of topics. So I've used Pythagoras, but it says find the area of the hexagon, given your answer to an appropriate degree of accuracy. This means I can choose my own. I can get the answer, but I can choose how I choose to round it, if I choose to round it at all. Okay, I've got a triangle. On most questions, if they ask you to calculate something, it's usually for a reason. They've asked me to calculate that, which is 8.66. It's usually for a reason. They don't just do it for the fun of it. Part A often leads on to part B, is what I'm saying. So have a think. Can I use what I've already found on the next part of this question? Find the area of the hexagon. If I can find the area of that one, this is the same as this, which is the same as this, which is the same as this. I can fit this triangle into that space, that space, that space, that space. What I'm trying to say is I can find this one, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 of these. I've got 12 of these triangles. If I can find the area of one, I can find the area of the whole hexagon. So I'm going to do the area of a triangle. It's a half times the base times the height. And I use a little song to help me remember this. I multiply the base times the height, then halve it. I multiply the base times the height, then halve it. Try and get that fixed in your brain. I multiply the base times the height, then halve it. I multiply the base times the height, then halve it. Keep saying it to yourself. I'm gonna multiply the base times the height. The height in this equation is the perpendicular height. When you buy yourself a Christmas tree, or if you go with your parents to buy yourself a Christmas tree, in the shop when they say the height, they mean the height straight up. When you buy a 6-foot tree, it is 6 foot straight up, isn't it? It isn't 6 foot along that way. You feel ripped off, wouldn't you? So when we talk about perpendicular height, we mean the height straight up. I mean the height that makes 90 degrees with this base. If I'm choosing this as my base, this is the perpendicular height, the one at 90 degrees. So I'm going to say my area equals base times height. I multiply the base times the height, then halve it. 5 times 8.66. Multiply my base times my height, then I'm going to halve it, which does give me a nice answer. 5 times 8.66 times 0.5 times a half gives me 21.65. I've got 12 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to do 12 times that number, which gives me 259.8. So the area of this hexagon is 259.8. Need to put some units in. Centimetres in the question, centimetres in the answer. Because it's area, I need to square those centimetres. 259.8 centimetres squared. I've just given the exact answer on my calculator. I've not felt the need to round. I could have rounded it to 260, but I've just kept the answer I've already got. Hope that makes sense. Slightly more challenging questions. It was worth a lot of marks though, an awful lot of marks, because it was introduced in Pythagoras, it was introduced in the area of a triangle, quite a bit in there. Here's today's challenge question. When you're ready, pause the video, give it a go, and thank you for joining Mr. A's Maths today. Join me tomorrow to see what question we have then. Bye for now.